So when we were discussing things backstage, we found, I think that a very good way of starting off our discussion is simply that you observed that people tend to trust robots or AI systems too much or not at all. Why is that? Why is there this gap between, why do people make that mistake? They never trust it just enough.
So people generically have two models of cognition. One is people and one is stuff. Stuff is dumb. You don't expect your toaster to actually be thinking and talking to you, and people aren't. So when presented with something that's like halfway in between, like a smart robot, about half of the population doesn't trust it and thinks this is like a lawnmower or a toaster, I can't trust it. And the other half jumps way past its cognitive abilities and thinks, well, this is as smart as my nephew is. And thinking it's as smart as your nephew is a very dangerous thing for most robotic systems.
Yeah, and I would say we look at trust. So at DARPA, we tend to express ourselves through our programs. And I would say one that touches upon this is called explainable AI, particular machine learning AI. And when you look at the complexity of the black box that is the neural network, it can certainly give us great performance. But we also would like it to provide us with an explanation of how it arrived at its conclusion. And so that we've embarked upon this program to try to provide that capability, where on one end you can have decision trees, which are very explainable, but their performance is nowhere near that of like a deep learning system. And how can we now move that and provide that so that the human user can work with its partner with understanding and trust?
And is it really possible to make a process used by a standard AI to be explainable to an average person who's going to be using it? Like, how can we accomplish that? Because it seems such almost an impossible task.
Well, I would say, just to follow on from our perspective, we have just started this program, but we do recognize that very point. And so one of the technical areas of this program is the psychology of explanation, and actually paying attention to how we as humans go about seeking explanation and understanding of a particular system. But maybe David has a little more.
So a lot of it depends very heavily on how the AI was actually built. If the AI is built out of behaviors from the ground up, people can understand behaviors. If you say, I walk towards this vehicle, it will walk away. If I walk back, it will follow me. They can understand those pretty straightforwardly. When you start getting into the hardcore parts of AI, and you start using machine learning and you have neural networks, not even the designers at times know what's going on inside. Mm-hmm. And if the designer doesn't know what's going on, how can you explain it to a user?
Exactly. And that becomes only exacerbated in complicated situations, morally complicated or physically complicated, if you have a group of robots working in a hospital or at a school or in a battlefield, in a war situation. There's ethical considerations, there's assumptions made by the humans involved which may or may not be reflected in the systems that the robots are running on. How do we communicate those differences? How do we stay aware of those and not make that mistake of attributing ethical behavior to a robot that has no such behavior programmed into it, essentially?
Well, I would say we are trying to look at that question in a more general sense, where, again, through a program we call Communicating with Computers, which really is looking towards establishing a symmetric communication between a human and a computer, where the computer is not there to just merely take orders, but to be a partner, able to collaborate through a range of modes, not just language, but gesture, facial expression. And it's worth just mentioning you can take one example where we as human beings, we tend to exchange complex ideas very efficiently, using ambiguous words within a shared context. Mm-hmm. So for example, I pick up 3 wooden blocks and I set them on a table. 1, 2, 3, I stack them that high. I turn to David and I say, just add 1 more. Humans get that effortlessly. Machines today are quite frustrated and will fail. So again, how can we now impart the ability to take into the aspect of context that the computer shares with its human partner so that you can, again, exchange these concepts very efficiently?
So this moves directly into the concept of having large groups of robots and large groups of people collaborate to do work together. Biologists have a term for this word. It's called eusocial systems, and one of the first ones would be ants. They've been very successful for millions of years. Yeah. And in an ant colony, the ants are segregated by work function, but they all collaborate cohesively to perform a whole. There are a lot of other models throughout the biological world, like a lot of small pilot whales are eusocial systems, and one beaches, the rest will beach to try to save its life. Biologists argue endlessly about whether humans are eusocial or not. We're kind of basically eusocial. Most of us will pull a small child off the road, but at the same time, we'll all violate the speed limit, or we'll pull in front of someone when we're driving in Boston traffic. And so within this concept of eusociality, there are these unknown, unspecified rules. If you're walking down a corridor in a supermarket and there's an old lady with a walker and she's struggling, you'll stand to one side and say, ma'am, can go past, can I help you get something? If there's 3 young football players coming down, it's like, I'm an old guy, get out of my way. We have all these deft ways of interacting together that the robotics community hasn't even begun to dive into yet.
Except in the trolley problem, which is asked every day in every ethics class, and we all know about 1,000 answers to that.
It's just worth noting, I think, what you can encompass a lot of that is just how do you impart common sense to machines? And that's a challenging question.
That's probably the trillion-dollar question.
Well, and you can partition it in such a way, just physical common sense of awareness of objects around you, that gravity exists, something goes to the edge of the stage and falls off. There's bulk to your chair. Then there's the next question of the common sense with human interactions. But we as human beings start to acquire this from day one. And there's an interesting challenge there of how we think that's important to impart to machines as well.
Is it possible, is it better to have a little common sense than no common sense at all? Because it seems like it might be one of those situations where if you have a little bit of knowledge, you do something very wrong because you think you're doing it right. But is it like an eye that you have to have the whole eye for it to work? You can't just have half the eye. But is that how it is with common sense and with making correct actions with context? Do you need the whole picture? Or can you work with just a small amount? Because obviously, I think getting the whole picture is an impossible task in the first place, right?
Well, I'm not sure. I think you can watch it when we raise children. Yes. There's a good question there. I mean, obviously, having an awareness that if I put my hand near a flame, that's going to hurt you, and you want to have the sense of not to do that. But I think there's a good question, where is that line? And I'm sure, David, you probably have some good points on that.
So if you look at biology, humans are born without common sense, and a lot of them get to adult ages without common sense. In fact, I've worked for a few of them. You probably all have too. So it's an acquired skill, and a little bit of common sense is better than none, and a little bit more is better than that. And eventually you get to a level where you're competent to perform a job and interact with other people. AI and computers and robots are a long way from that baseline point. And one of the challenges facing the community is the technology for perception and actuation and pattern matching is proceeding much faster than the technology behind common sense and ethical decision making. And this is creating the potential for like a nuclear arms race of systems that are too smart, too fast, but have no basis for making good judgments.
So how do we go about making those systems? I know that you've looked into some of this, but is it worth it to just sort of go for that moonshot and be like, I'm going to try to create a robotic conscience. I'm going to try to create an ethical system for robots, a set of nested rules that can never be violated, like, obviously the laws of robotics. Is that something that's worth pursuing, or is that a rabbit hole that you can go down and never appear from because you will never produce a viable piece of software that will actually run?
That's a DARPA hard question.
Well, it is. I guess I like to look at it from this hierarchy of data through wisdom. And so you have data, information, knowledge, and wisdom. I like to insert between knowledge and wisdom understanding, which can be represented by causal explanatory models. So we are making progress going up that sort of ladder, where of course we take it almost for granted today that machines are very capable of low-level data information processing. We're starting to make headway in terms of knowledge graphs, relationships between facts, but even now moving into the generation of causal explanatory models from text, from data. All this I think you'd want to establish first before now you tackle this aspect of wisdom, or what I would consider sound judgment. And common sense gets into that space.
So going back again to the biological analogy, ant colony has no philosophers. They have no pope. There is no 10 Commandments.
Are we 100% sure of that?
A good point, but probably. Even most more advanced creatures that don't have spoken language don't have any of these things, and yet they have figured out behavioral ways to operate ethically in large groups and get things done. Yeah. And so rather than an abstract, we must achieve human intelligence first, and then we'll make it ethical, it would be better to start building ethics in at the ground level, because by the time we have achieved human intelligence, if we haven't made it ethical, it's too late. We've built a super smart sociopathic robot system, and then we have Terminator Day.
Well, that's one plan. DARPA, are you working on that?
No, I think it's a very relevant point. It's fair game for an idea to start something new, too. So I like it.
DARPA's working on a sociopathic robot, everybody. That's the new
not sociopathic.
news breaking from TechCrunch.
How we can have the inspiration, as David points out, from other social systems.
Yes, it would be better.
I think it's a very good point.
Yes, certainly.
It would be better to begin to work on use social robot systems where the robots can place value both in the people they're collaborating with and the mission they're trying to get done. And so if you look at examples of people behaving socially, we do a lot of work in medical robotics, and if you watch a trained surgeon work in an operating theater, it's this fascinating symphony of 4 or 5 people speaking very few words, but they know the mission is to save your life. And the doctor will stand there and just put out his hand, and the scrub nurse will put the right tool in it.
Yeah.
And they have practiced this, and they've collaborated, and with very slight gestures, very slight notions, and a preconceived idea of the mission, they let you live for another 30 years. There's no reasons robots can't work at that particular level, even before we've achieved full sentient intelligence. But you have to want to do it, and you have to build those precepts into the code you're writing. You have to be thinking in terms of people and robots collaborating on a joint mission in a very careful way to pull this off. If a surgeon puts out his hand and asks for the wrong tool, a scrub nurse has an ethical dilemma. She can argue with the chief brain surgeon at Brigham Women's, the smartest guy on the planet Earth, that you don't really want that. Or she can hand it to him and he can do the wrong thing. And she has this ethical question to challenge. That's like, I've done this operation 1,000 times. I know this is the wrong tool. He's been awake for 35 hours. He's sleepy. I'm just going to give him the right tool. We want our robot systems to do that. We want them to be able to make those type of decisions. If you're in a warehouse with a robot, if you're in a platoon with a robot, if you're in a manufacturing facility building an airplane with a robot, you want your robot to know what you're trying to do and to help you.
So how do we build that trust with robots? Because we have the same problem with robotic systems and with AI systems as we've had with computers for 40, 50 years, which is garbage in, garbage out. And the systems that we create mirror the biases that we have and the problems that we have in the societies, the societies and people that create them. So how do we address those problems? How do we prevent our systems from having those same flaws? Do we need to have some kind of system of accountability for our data sets, our systems? Who's looking out for the garbage, whether it's going in or coming out?
Well, I think certainly there has to be a view on data in itself as its value, because data, of course, is very critical to the training, at least in the context of machine learning AI systems. One aspect that certainly we're looking at is this question of integrity of data. Now, that has to do more with its interpretation, but what this effort is looking at is the fact that there is a multitude of techniques to manipulate images for good or bad, generally for good. We want to make ourselves look better in a particular photo, but there's a ton of those kinds of tools, and so we've been looking at, can we come up with a tool that can detect manipulation in images, for example, at the pixel level, or physical inconsistencies in the scene itself? And then perhaps even a semantic kind of integrity. Is it consistent with other images? So that's just one step, looking at how one can provide an assurance on the integrity of the data itself. Now, what you're getting into is the aspect, how can it play into the training of machine learning systems and awareness that how one might want to present a diversity of training sets to cover this. But I think, David, you've been looking at this as well. So.
The path forward is to collect a lot of data sets of robots interacting with people. This is basically a training issue. How do you train a 2-year-old and a 4-year-old and an 11-year-old to interact? If they're brought up in isolation, they basically don't know how to interact well. If they're brought up in daycare and they're interacting with kids since their age of 5, by the time they're socialized, they're far more socialized than some students since it's been brought up at home alone. And so robots are the same way. The basic goal would be to have them interact with people at a non-dangerous, non-lethal level and begin to build up some of this common sense and then collect a lot of data sets to begin to train on.
And where are those data sets going to be? Because this is one of those issues also as far as practical threats to this kind of thing. The data, of course, and often the logic behind robotic behavior is living in the cloud, and that opens up a lot of area of surface area for attacks and for manipulation. There's a lot of steps that we're not directly in charge of. If you're just the person interacting with a robot, there's not a lot of like I wouldn't have a lot of confidence that the response that I'm getting from a robot has not been manipulated or is not being tracked in some way. Is there a threat there? Is this a new threat model of like are our hotel robots going to be turned into killing machines by 4chan hackers or what?
Well, I mean,
kind of a multifaceted question.
Well, yeah, and it gets to the whole question of cybersecurity in general, but specifically applied to these systems. And it encompasses not just at the enterprise network level, but also at the individual systems themselves, which we consider the category of embedded software systems. And yes, you have controls now for these systems that tend to know how to address random type of faults or errors. But when you start to include malicious activity as part of that, we don't have control systems that can handle that. So now how do we go in and maybe make these systems more intrinsically hardened to a cyber attack? This takes you down the path of how we build software using techniques such as formal methods, where software is executing as specified. And of course, the key is the specification. And that takes a little more in the embedded space. But yes, there's a host of techniques, and I think you have to pay attention to it because there is a malicious activity, and we see it every day on the web, for example.
So social robotics is a little harder to quantify because each social interaction, whether it is a social one or work one, a military conflict one, has its own rules of engagement. And there are no set norms across the whole of mankind. Even within military rules of engagement, every country has its own set. And so you end up with a myriad of training sets that are specific to a specific area. The way you interact with your robot tractor might be very straightforward because farming is fairly consistent. The way you would arbitrage and interact with a robot stockbroker is probably totally, completely different.
And of course, we see in social engineering humans interacting with other humans through phishing, spear phishing. And the interesting question is how perhaps there's this potential for chatbots to play a role in that kind of intermediary between in that space.
And sort of on the topic of weaponization, I don't want to mischaracterize DARPA too much here, but I'm curious how, especially in the field of AI and robotics, how you see your mission in stewarding new technologies while balancing that concept with that of military applications, essentially. How do you do that responsibly?
Well, first of all, you have to take very seriously the importance of sound judgment, because decisions in the case that we deal with, the environment we're in, can have life or death consequences. So you really do have to pay attention to that. And that's why you have to look carefully at how one can step up to, we mentioned earlier, common sense. How do you have the system do what you want it to do in the ethical, legal manner? We're not there yet. We do pay attention towards where we can apply autonomy in environments, such as we're seeing it in cyber, for an example, where we can apply automation to the detection and patching of software vulnerabilities. So try to use it in that manner. But again, it comes down to the aspect where you can still impart the human supervision on these systems, which may have to take the form of how this human designer imparts constraints and bounds on the system.
So mankind has been weaponized and militarized for the past 35,000 years. The odds of them still being weaponized and militarized in the next 1,000 years are very good. That would be an interesting bet to win in a bar. Given that that's the groundwork of the terrain, in order to protect our democracy, in order to ensure that the United States goes forward as a free entry, we need to have a military. And that military, whether they choose to or not, will end up with a lot of robotized systems. In order to match a technology gap with opposing forces, in order to achieve parity with people that don't want the United States to exist, it's not a question of should you have it or shouldn't you have it, it's just an accomplished, accepted fact. Having accepted the fact that you have militarized robots, now the question is what are the rules of engagement? Where are decisions made? Who can make those decisions? And one of the dangers in the cyber conflicts is the speed of those decision making is getting so fast that you can't actually put a human in some of the loops. And that's where the challenges lie within the future.
So it sounds like we only have a little bit left, but I wanted to ask, that sounds like an issue that's you think should be discussed more. Are there any other issues that either of you feel is not being discussed enough in this space of the interactions between humans, robots, AIs? Is there something that is being discussed too much, something that is not being discussed enough?
I think we want to get the discussion onto a level that is realistic, where we can apply rigor. I would say at times, of course, things can give rise to certain fears, but I think we can address them. And again, taking a methodical approach certainly makes all the sense in the world.
I think the one space where has not been discussed enough is how to initiate and begin to inject ethics into all different branches of robotics. There are classical ethical questions that people play around with in academic settings, but right now, the audience, people are writing robot code. And I'm challenging all of them. It's like, well, how do you work ethics and how do you work doing the right thing into that code from day one? Because if you don't put it in today, it might never get there.
Very true. Well, thank you for joining us. Some very interesting insights from you guys, I'd have to say. Thank you very much.
Thank you, Devin.